Welcome back. In this chapter, we're going to begin meteorology. And meteorology is the study of weather. And weather is caused, or the background cause, would be the heating of the earth by the sun. And the heating of the earth is not the same. If the earth were flat and the sun were shining on it like a piece of paper, where everywhere on the paper would get the same amount of heat, then you probably would not have much weather. But in the case of a round earth, a spherical earth, some of the intense light, or some of the light from the sun is going to be more intense, and some places less intense. This uneven heating of the earth is what causes the winds to blow. And it also causes the water to absorb into the air because you have some air that's colder and some air that's warmer, and that's holding on to different amounts of moisture. So if you have different amounts of moisture, different speeds of winds, all working together, you have weather, and meteorologists study weather. So let's look at the beginning of this. So we're now in our next branch of science, and that is meteorology. Now, most people know that a meteor is like a shooting star. So a meteor is a big hunk of normally iron or nickel or something that was left over by a comet floating around in space. And as the Earth goes around the sun, it bumps into that piece of debris and it catches into the gravity field and falls through the air, and you can see it streaking through the sky. There are certain times of year where you'll see that more than others. Well, that is a meteor. But the word meteor has an old Greek word, basically is anything that falls. So a hydrometeor would be water. So that would be rain or snow or sleet, something like that. A lithometeor would be anything like a meteor, or it could be something small like dust. So a sand cloud or something like that, a sandstorm, those would be lithometeors. Electrometeors, very interesting, where a lightning is actually shooting from the sky. That's called a meteor. So meteorologists are studying weather because that really is the common between all of these things that are falling, is precipitation, the stuff that's in the air, embedded in the atmosphere, and then the electrical storms that relate because of the static electricity caused by this moving water. So we come to a very, very basic question. What is weather versus what is climate? And weather is something that is localized. It's right here. Weather is what is the meteorology of this area right now. Climate is much more generic. Climate could be over an entire, say, a continent or over a broad area. So it's usually bigger. And it's not necessarily for this particular day or that day. So like the weather on Tuesday means that it could rain or snow. The climate in a certain area normally doesn't happen whether it's going to rain or snow unless it rains or snows so much that you could actually classify that whole area as somewhere that it always snows or it always rains. And then that would be part of its climate. So climate's a more generic term. I've mentioned this several times, a lot of what drives weather is the uneven heating of the earth. So the earth's surface is heated by the sun, by radiation, solar radiation, but it occurs in an uneven way. Okay, so first of all, we see that the earth is tilted, that the equator is not always going to be lined up to the sun. Sometimes it is on the equinoxes. You would have the same angle of equator on both sides. But in the case of winter, and this is an example of our winter, the northern hemisphere is away from the sun. The southern hemisphere is towards the sun. And now if you were to look at the rays of the sun, you have the direct rays of the sun hitting at the equator. That's much more intense light. If you were to shine a flashlight directly over a table to where it's a nice round circle of light, all that light is in a very small space. That's intense light. If you were to stretch your hand out so that the beam from that flashlight went over a huge space, a long space, where you're stretching out that beam and making it very oblique, Well, what's happening, you've got the same amount of light over a longer patch of ground. That means it's not going to be as intense. So the oblique rays at the South Pole, in this case, is going to cover a lot more space than the direct rays at the equator. And so what's going to happen, it's going to be warmer. The ground is going to be warmer at the equator and less warm at the poles. Because of this unbalance of heating, you can get these circuits of air that we've talked about before, where warm air rises and creates a low pressure where that air used to be, and then a high pressure where all of those crowded molecules are up higher in the atmosphere. So as you pile up air and stretch out air based upon the uneven heating, that is the main driver of weather. We now come to the masses of air. So these masses of air essentially are, where is the air sitting? If it's sitting over a continent, then it doesn't have a lot of water to draw up. Remember, every air can hold water. Every temperature of air can hold a different amount of water. So if you have air that's over top of an ocean, there's lots of water to draw up. It's like the sponge sitting over the pool of water. There's water to soak into the sponge. If you have air over a continent, that's much more drier. If you have air over the tropics, okay, over the, say over the equator, then you're going to have much warmer air. Okay, if you have air over the Arctic, you're going to have very cold air. So if you blend these airs, their airs can either be cold or warm, wet or dry. And now these types of airs are all given names, okay? So you can have maritime tropical, that pink one. So maritime means over the ocean. Tropical means not at the equator necessarily, but in the very warm region of the Earth, near the equator, okay? So you have maritime equatorial, that would be on the ocean, right on the equator, very, very hot. Maritime polar, okay, so towards the poles, so it's cold, but it's also on the ocean, so it is wet. So you have moisture and temperature in these various types of air. So let's look at the ones next to North America, okay? So the tropical ones are towards the south, okay, because south is towards the equator. The maritime ones are towards the ocean. Continental would be towards the continent or over the continent. And then polar or Arctic would be towards the North Pole. So you can have continental Arctic, continental polar, okay? So polar is towards the poles. Arctic is in the Arctic zone, so that's much colder. And then the maritime polar would be cold and wet. And then the continental polar is cold and dry. The continental tropical is warm and dry, and the maritime tropical is moist and warm.